This is video 19 in the thermal course, and this one is about pressure dependence of equilibrium. I start with this general equation, which is actually equation 14.1 in the textbook, and I have replaced the fugacity coefficient with a large phi in this case, and this large phi is the fugacity coefficient divided by the saturation fugacity coefficient for a pure component times the x of minus volume of the liquid times P minus the saturation pressure over RT. And the saturation fugacity coefficient is the correction factor for non-ideality at the reference state, which is at the saturation pressure of the component, and at low pressures this can be neglected. Actually, it is at low saturation pressures because the pressure might be high while the saturation pressure is low. So formally, this is at low reference pressures or P-sat pressures. The last, the exponential term, is the pointing factor. Or pressure dependence it is normally neglected up to moderate pressures about 10 bar. So that is even higher pressures than here. The gas is normally not regarded as ideal, but the pointing factor can be neglected, and then when both factors are neglected, then we end up with the more traditional equation, where we treat the equilibrium with one correction factor for the vapor phase, which is the fugacity coefficient for the vapor phase, and one correction factor for the liquid non-ideality for the liquid phase. And this is valid except for high pressures. One example. Where the pointing factor is about 5%, is the fugacity coefficient for water in natural gas at 60 bar, which is an application of TEG dehydration. Of natural gas. TEG is a glycol. And in gas processing, in natural gas processing, the pressure can typically be about 60 bar, and then this pointing factor might be important. And in the case of the fugacity coefficient of water in natural gas at 60 bar, then this pointing factor counts for about 5%. But this pressure dependence is rather complex or difficult in thermodynamic theory. However, the good news is that for most applications we can neglect both the fugacity coefficient at saturation properties, and we can neglect the pointing factor and end up in this much more simple equation. So that is the end of video 19.